Our next link challenge is related to the game of chess. And you know the drill by now. I'll explain the problem and then you see if you can come up with a solution. Now this one is a little bit more tricky than the ones we've attempted so far. On a chessboard, the bishop can move any number of squares diagonally in a single move. And the challenge is, if a bishop starts on square c6 on an empty chessboard, then what positions can that bishop reach in a single move? And so the output of this challenge is to create an enumerable sequence containing the names of each square this bishop can move to. For example, it can move to b5 and a4, as well as b7 and a8. So how can we solve this? There's actually several different ways you can tackle this, but I'm going to suggest we go for something fairly simple. We'll enumerate through each of the 64 squares on a chessboard and filter out the ones that the bishop can't move to. Now, there are ways of solving this problem without needing to test quite so many squares, but for the purposes of this challenge, the performance difference will be negligible. So, how can we enumerate through all the squares on a chessboard? Well, one way to do it is to go through every column, which in chess is also called a file, and then for each column enumerate through every row, which is also known as a rank. So we'll start off by using enumerable.range to go through the columns A to H. And we could start this enumeration at 0 or 1, but to make displaying the positions easier later on, I'm going to start with the character code for lowercase a, and I want to enumerate through 8 values. So that's A through to H. And for each column, there are many rows. So we need to use select many and return something that represents a board position. So the next decision we need to make is, how will we pass around the row and column, or rank and file, through the stages in our pipeline? We could do this simply with a 2-character string, or we could use a tuple, or maybe even define a class to represent a board position. And that's something we'd certainly want to do if we were writing a whole chess game. But for now, I'm going to go with an anonymous object. So, using select many, for each column, we'll use enumerable.range to generate a sequence of each square in that column. And this time we'll start with the character code for the number 1, and we'll use the 2-parameter version of select many, which does improve readability a little because it allows us to pass in another lambda function that combines the values from the inner and outer enumerations. And so we can now create an anonymous object containing the rank and file of the square, and I also need to cast these into chars, as the enumerable.range method will always return integers. Now don't worry if that was a little bit confusing. When we run, you'll be able to see that what we've ended up with is an enumeration of all 64 positions on the chessboard represented as anonymous objects. So our next job is to filter out the ones that the bishop can't move to with a where method. And one way to do this is to say that a bishop can move to a square if the number of rows it is away from the starting point is equal to the number of columns it is away. So it's on a diagonal. And we can do that by subtracting our starting position from the coordinates of the current square that we're checking, and making use of the math.abs method to make sure that negative numbers are turned into positive. And so now when we run this, we can see that we've nearly solved the problem, but there's just one issue. We've not filtered out the original starting position of the bishop. And staying where you are is not a valid move in chess, so we need to add one more where clause to remove the starting position, which we could do like this. And finally, we might want to add another select statement on to format this into a sequence of strings to make it display a little bit nicer. And so now you can see we've solved our challenge, and we have managed to do it in a single C# expression again. But I think you'll probably agree it is a little bit hard to read in its current form. And it also has something that I really don't like, and that's the fact that the starting column, which is C, is expressed in 2 different places. And so if we wanted to change the starting position, we'd need to remember to change 2 lines of code, which is a bug waiting to happen. Now, if we wanted to fix that, but still keeping our solution as a single C# LINQ expression, then one way we could do that is by creating another stage in our LINQ pipeline with a new anonymous object that contains dx and dy values. And these are the distances of this square from the starting position in terms of rows and columns. And then that allows us to filter out all the squares that the bishop can move to with a single where clause without needing to repeat the details of the starting square. But really, although this is a clever solution, have we made an even more complicated mess of solving a fairly simple problem here? Of course, it is fun to try and solve things like this in a single LINQ expression when you're doing a coding challenge, but in the real world, you should be prioritizing readability over showing off how clever you are at cramming lots of logic into a single expression. So now that we've got a solution to our challenge, how can we improve the readability of this code? Well, one very simple thing we could do is to break this pipeline up and give intermediate names to the different stages. And if you think about it, this solution has got 2 logical parts to it. The first part gets all the positions on the chessboard, and then the second part filters out the ones that a bishop could move to. So let me just switch LINQ pad mode again here so that we can have multiple statements and declare some helper methods. And so we could take the first part and call it chessboard positions, and then the second part could be called valid moves. And by assigning these intermediate names, we haven't actually changed anything about the way this pipeline behaves. We've just made it more obvious what each stage is doing. And we might want to go a step further, like we did in our last LINQ challenge, and create a small helper method. And we could call it bishop can move to, which takes the starting position and the target location and returns a boolean saying if the bishop can move there. But there is a bit of a problem when we try to do this. Because we're using anonymous objects to represent positions in our LINQ pipeline, then what type can we use here to pass them to another method? And this is an unfortunate limitation of using anonymous objects. Now, is there anything we can do to solve this? Well, there are a few options. One option is we could use the C# dynamic keyword like this. And this would allow us to get rid of this ugly select, and in the where statement we can now call our method. Now, this approach does work, but by using dynamic, you're starting to lose the benefits of using a strongly typed language. And so really, at this stage, when you're wanting to pull out part of your LINQ pipeline into a helper method, you should pick one of the other options we discussed for storing chess positions, like a class, for example. But here I can still keep it fairly simple and just use 2-character strings. And to save you watching me refactor this, here's a version I prepared earlier. It has 2 helper methods, one called getBoardPositions, which is using select many to return all the chessboard positions as strings, and then one called bishop can move to determine, using the same technique we saw earlier, whether the bishop can move to that particular position from the specified starting point. And so with these 2 helper methods, we've actually managed to clean up our LINQ pipeline considerably. It's now just got 2 stages if we ignore this call to the LINQPad dump method. And we've got some nice side benefits here as well. This getBoardPositions method is probably going to be useful elsewhere if we're making a chess program. And these 2 static helper methods are also going to be really nice and easy to unit test, which is a topic we're going to be coming back to later on in this course. Now, I hope you'll agree that this version is much more readable than the original solution we came up with. Yes, it is a bit longer, but these 2 helper methods just contain implementation details which are not needed to understand what's going on in our LINQ pipeline. But before we do our last LINQ challenge, I just want to show you one alternative way that we could have made this LINQ pipeline easier to read.